Okay, in the last part, we actually imported our biome settings and made sure that the terrain follows those settings and groups parts of the terrain according to those settings. At the end of the episode, I alluded to the fact that this system does work, but it's not very scalable. So what we're going to start with is to make our custom table import. I'm going to use a Python sub for this. And to start off, I'm going to slightly adjust the interface. So press the gear wheel and edit parameter interface. I'm going to add a folder and another folder. I'm going to drag this into the second folder. I'm going to call it code. I'm going to call this controls. Okay. In the controls, I want to have a string parameter called file path. And I want to have a button. And this button will simply reload the node. So if I go in here and type how.node dot, which basically points to the current node. Alternatively, you can say pw, which does the same thing. Dot cook true. So it forces the cook of the current node. And to demonstrate this, in the code I'm going to print hello world. Okay, so if I clear, go to controls, reload, you see it re-executes the code. So that's a quick way to actually refresh the file. So you can simply copy over this into the file path. And now we can actually start building our code. For our code, we actually do not need the information of the node, of the geometry itself, or at least not until the end. So I'll leave it in, but we're going to use that later. First, we are going to import the CSV library, and we are going to get our file path. So file path equals how.parm. If you don't specify the node, it will always be the node itself. File path, already highlighted, evaluate as string. So now I can print file path. Go. Now it actually prints out the file path again. Okay. So with opening the file, as a CSV file, just a variable that we're going to use. We're going to add a reader, which is csv.dict reader. Because in the CSV file we use a header system. So if you don't have a header system, you can use a normal reader. Okay, dict reader, and that is going to be CSV file, and the limiter is going to be a semicolon. Okay. Then we can actually start using the dict reader to query some data. So the headers are going to be reader.field names. These are all functions that you can Google inside the help files for the CSV library. I'm just going to quickly check that works. I think I'll just leave the console here for now. So yes, we can see biome name, bio weight, occlusion, slope, mesa, cliff, water. So that all works as expected. In Python, the comment character is the hashtag, if you will, or the old number hash. It's properly called. So we're going to count the amount of columns in our file, which will be then headers. And we're going to initialize the data for the columns. So columns equals creating a new array for int in range and call. I think, yeah, because intuitively you might decide to write in Pythonic something like this, but this will create the same instance of the array this amount of times. And if you do that, whenever you write to one of the arrays, it will write to all of the same index of all the arrays. So you will not actually be able to write the data in as you would like. So now we're going to simply go through the rows. So for row in reader, and then we're actually going to go through the columns as well. But in this case, I'm just going to use call as an integer. Because I need to actually use that to get the information out of the array. So the current cell is going to be from the current row. I want to have the current column. Okay, so if I print cell, I should get all cells. Okay, so I'm forgetting something. Syntax error, columns in range. Okay, so did make a mistake. Oops. There we go. Yes. So now we get all the information. Again. Yeah, we actually have a reload button, so let's use it. Okay, yeah, that seems correct. Good. Okay. So because we know that in the first column, so that would be occluded, open, cliffs, it's a string attribute, and all the rest are float attributes. So we need to actually make a case for that. So if call equals 0, we're just going to put the value as is. And otherwise, we're going to convert it in a float. So yeah, what I'm doing here is for the current columns, I'm going to simply add the current cell. So I'm actually resorting the array into one array per attribute instead of per biome, transposing the data. Okay, don't need that anymore. Okay, now we actually need our geometry again. Actually, I will Alt E. And now we actually need to create points to actually hold this data. Alternatively, you could write it all to a detail attribute, but because the points are a nice container of the information, we're just going to use points, just like the table import. To do this, we first need a tuple of the amount of points that we need to add, because in the Houdini library for Python, there is a geometry.create point, but that is actually quite slow if you have to create a lot of points. So instead, we'll use the create points, and that will actually accept a tuple of point positions. So let's actually create that tuple. And it can also be a list, I think. So I'll just say, because we don't really care if it is, yeah, we just need them at 0, 0, basically. Yeah, we just need to know how many rows there were in the CSV file. So that will be just, because the amount of rows will be the same for every column, we can just pick the first column. I think that should work. Okay, I think we have points. So we have 3 points. Okay, so that matches the amount of biomes that we have. So that seems correct. Okay, so let's actually store the attributes. So for the attributes, let's generate them first. And then again for I in range of 0 to n col, we want to actually add to this array a new attribute. So we use the geometry. Oh, no, the geo dot add attrib, which is going to be a how attrib type dot point. This is going to be the attribute is going to be called headers I, So we're just going to use the top of the CSV file to actually name the attributes. And then we're going to make the default value from the current column, this current header, first entry. So we know if it's going to be a string or a float attribute. And we're going to not call the transform this data by normals, and we're not going to create a local variable. If you wish, I can quickly look up the documentation for this. Okay, so Houdini Python. That's hoping actually. No, it doesn't at all. Hoping. Let's just go to Google first. Houdini how.python Houdini Python yeah, how.geometry. Okay, there we go. Okay, so yeah, if we go to add trip, you can see here that transform as normal false, create local variable true. So if you just specify the first two of the function, it will not create it as a normal, but it will create a local variable. So if you don't want to create a local variable, you need to add false, false, which is what we did. Okay. So if I cook that, wait, let's apply. Okay. Syntax error. I'm guessing I've got one of those. Attributes is not defined. Typo there. There we go. So yeah, now we can actually see that we actually have all the attributes. And right now they all have the same value that was in the first row of the CSV file. So now we actually need to make sure that we set all the data instead of just the first row. So for I in range of 0, then points. We actually need to make sure that we write this new points to an array, to a list. 0 points. And then for every column, we're going to actually write over the information, set metric value. I'm just going to fetch from the array the attributes class, so the attribute object. You can also use the name, but because we already have the object, we can just reference it like that. And then we want to, from the current columns, we want to get the current row. So yeah, so we're going through the rows here, through the columns here. So from the current column, we want the current row. Yes, I think that should work. Yeah, so okay, now we actually see again this. So if I go back here, the result should be the same. Yep. So we now actually just reproduce what we did in the table import. But the advantage is if we add more columns to the CSV file, they will automatically be added instead of having to actually specify them again using this multibar. So I'm going to table import dynamic. So now we made our system even more scalable. Okay, so yeah, just to demonstrate that all still creates the same biomes. No difference. If I disconnect it, it should no longer. Oh, if I do this, it should stop working. Yes. I guess I probably should demonstrate that. So let me quickly open that file again. Go. Give me 1 second. Yes, let's open that. So if I would add an attribute, test 0.1, 0.2, 0.3, save that, keep the format. And if I go to the geometry spreadsheet, it doesn't add it yet. Oh, I just use the, be very careful when you're actually using a scroll wheel when hovering over a parameter. If you can see that you actually can also change strings this way. And sometimes this is a bit dangerous when you're actually editing code. So be careful when you do that. So now if you press the reload button, there we go. So it added test. So just be aware that it doesn't add it in the same order as it does here. It always will take the alphabetical order. So let's get rid of test again. Save, press reload, and it's gone. Okay. So right now, what we could do, basically like what we have right now, is use this biome data to set up materials for certain areas. But if you actually want to bake stuff like a splatting mask or map, it's probably a better idea to actually promote the attribute to quickly add a point using Alt. So if I, oh, no, there we go. Go from point to primitive. Oh yeah, and then actually copy this as well. And put this on primitive. But right now it won't work because there's already a point color. And if there's a point color, it will override the primitive color. So we need to delete the point color. Yes. Okay. So now we will get the average biome. But if you're actually using an index, that's not very safe. So usually I would go for a mode. So now we actually have like a hard edge. And this is important if you're using a splatting map because it will use the index to specify what material you're using. And if you're using a smoothed result, then if you're fetching stuff in the blend area, the index will be in between the two, and it will generate just a random material in on all the edges between all the regions. So if you go for the splatting map approach, you should definitely first promote it to primitives, and then maybe if you need point colors, you can use a vertex split. So what you then can do is from primitives go to vertex, and then you can use first match, and then using the vertex split you could use that should actually, and then if you promote it, you can see that it is again CD. Oh, it's still primitive attributes. Wait. In this case, it would become, yeah, biome index. Oh yeah, because the color is still, okay, fine. And then CD would be here again. So we can disable that. And now these are both point attributes, CD, but you still have the hard edge because it will actually split the points. You can see like the numbers overlapping. Before it doesn't. Or you can keep them as primitive or vertex attributes, whatever your pipeline uses. Okay, so for just the materials, this will work just fine. But for other purposes, you might actually want to filter out areas like this, because you want a more nicely shaped area, so you don't have a lot of jittering. Like if you want to avoid having a lot of very small details that seem out of place in a area that's otherwise mostly a different type, we actually have to introduce some more filtering. So I'm going to use some more wrangling for this. And we're actually going to go through 3 iterations for this filter. So first off, I'm actually going to use the trick. Well, it's basically recreating a partition sub, but it's using just a single record node. So I'm actually going to add a string group. Printf biome group underscore modulo d percentage sign d. So this will be replaced by the underscore biome index. And then we are going to set the point group. Okay, so now we should have 3 groups. Yes, biome group 0, biome group 1, and biome group 2. So these all match the biomes again. Then I'm actually going to use a promote sub to make sure that I always have the highest biome index. So from point to detail, the maximum, and again, biome index. Okay, so now we have one detail attribute here, which is just 2. So 0, 1, 2 is the highest biome index. I'm going to add another wrangle node. This is where we actually do the code. So what we're actually going to do in this wrangle is compare in a range around every point if the amount of biomes of a different type is larger than of the current type. And if that is the case, we're going to use the type that is the most common. So let's start doing this. So first we're going to specify our range, float range equals chf range. So that will actually add our range here. And then we're going to get our group, which will be the same as this, basically. And that's the current biome group. Then we will have to count the amount of points of the current biome in the range. Same class points equals the length of the near points function of the first input using the current group, so the current biome, from the current position inside our range. Okay. So let's say our range is 10. And I'm going to pick a point here. So 5, 2, 9, 5, 5, 5. And I'm going to use printf. Always be careful when you use printf in this way if you're not using a group like this, because then it will try to print this debug for every point in your geometry, and that might actually take a quite long time. So I'm just going to use do this for 1 point. And same class points. Get the debug window up again. Okay. So yes, we have 19 points of our current biome. And if I would not specify the group, we actually have 280, 98, 89, sorry. Okay. So what we now can do is actually check the difference between points in this current and points in the others. So what I'm going to do is create arrays, other, or an array of the other class points. And this is going to be we add group back in. The near points of 0 inside what is not the current group. Again, from the current position and the current range. Okay, so now we have the length of all the amount of all the points that are in the current biome and all the point numbers of all the points that are not in the current biome. So now we need to initialize some more variables. So int other biome in I and n other class points, which is the length of this other class points, which we will just use to loop over this amount. And then we also want to make some more attributes for biome count and the maximum biome, which is detail 1 max biome. Yes, well, right now it's not yet max biome, but if we change the name here to max biome, now it should be called max biome. Okay, so now we have some data and some arrays. So now we're going to start to loop. Again, our code starts to exceed the amount of stuff that I can show on that window. So for I, which we already initialized, so we don't need to specify int in this case. If you don't put it here, you actually have to say int I is smaller than n other class points. So we're just going to loop over all the points that are not in the current biome. And then we're going to, for each point, check what the biome is. Biome index, other class points. There we go. So, and then what we're going to do, yes, actually I need to make sure that this array is resized to the amount of biomes. So max biome. Is that correct? Because I think I need to do +1. We'll check later. Okay. So now what we're going to do is biome count. Biome ++. So whenever we find a point in one biome, we're going to add 1 to that count. So then we're going to again use the argsort argument sort function, which is sort biome count. Yeah, because the max biome is 2, but the amount of biomes that we have is 3. So 0 is also included. So I'm just going to specify this one here. And because of the resize, this was actually changed, I think, in Houdini 15 or something, or at least, or maybe later versions of 14. Before, resize would not automatically set all the values to 0, but now it should. So basically, it creates an empty array, or an array with this size with values that are all 0. So now we actually have the amount of points per biome. And we just need to actually update the biome index. So first we need to check if any of the points, any of the biomes have more points than the current biome. So what we can use to do this is biome count, and then the index is going to be the last index of biome sort. And you can, instead of using length -1, you can also just use -1. This is something they added in 15 or 16, I think. So in earlier versions, you might need to do len max biome sort -1, because it's now actually using the same logic as Python for splitting arrays and strings. Is larger than and same class points, then we're going to actually update the current biome index, which is max biome sort -1. Okay, so now if I press apply, this one point might change color. Okay, so I made a mistake somewhere. Let's actually save first. Okay, I made a typo somewhere. There we go. So now I've already removed the print function. So I can start cooking this. Now it actually starts cooking. And there we go. So now we can actually start to see the difference before and after filtering. I'm also going to disable the lighting. So now it creates more blobby biome shapes, and you can just adjust the filtering by basically tweaking this range. So the smaller this range, the more detail it will keep. But I think 10 is probably a nice value for this. Okay, so there is actually like one point for here, is that this right now is just one iteration, and this point was actually flipped because it found a lot of biomes of this type, but because of the result of the other points, it's still surrounded by, again, a different biome. So what we're actually going to do is to start putting this in a loop. So this is going to be called, also I'm going to manual update mode. So partition points, flip biomes when minority in radius. And now we're just going to add a for loop with feedback. In 15 and 16, this is called just for loop. And in 16, make sure that you actually put it on feedback each iteration instead of merge each iteration. So simply copy paste that. One more dot there. And in the loop, we actually need to do one more thing, which is a group delete. And we're going to delete all the biome groups, because otherwise it might still use the biomes from the previous iteration of the loop, and then our filtering won't work. So now it's copying over the color and put the amount of iterations on 1 first. Okay, let it cook for a little moment, and if I select this one, it should be the same result. So from this to this, it should be the same as this. Okay, it is. And now if I start increasing the amount of iterations, it should start filtering all these small points as well. Okay, so it does filter the one point that I was looking at, but again, it was introducing more artifacts there. So, and I think it also like removes more detail again and again. So to actually counteract this again, I'm going to create another iteration of this filter. I'm just going to copy paste this entire loop again. And I'm going to press the block begin and create a meta import node. I'm going to drag it here and put this there. It's now set to fetch metadata. So if I'm going to go again to iterations 1, pardon me, let's just cook it to make sure that we have all the attributes. Okay, so what the metadata import fetch metadata does, it creates a set of detail attributes that are linked to what the current iteration of the loop is. So if you go to geometry spreadsheet, there's the iteration, I value, num iterations, and value. And I think in this case we're going to use I value, because I value is basically start value, and then +1 for every iteration. Iteration itself will start at 0, so basically it will do the same as if this value was 0. But in our case, we just want to keep it at 1. Yeah, so there are cases where I value and iteration will be the same, but not in our case. Okay, quickly look something up. Yes, okay. So what we can then do is quite simply adjusting the range here. So range is going to be divided by the current detail of 2, and it's going to be I value. And this is why we want to keep the start value at 1 instead of 0, because otherwise we would be dividing by 0 in the first iteration of the loop. But because we're dividing by 1, the first iteration of the loop will just be the normal range, and after that the range will decrease every time. So again, let's start actually comparing. I'm going to put this on 2 iterations. Okay, it already is. Put this one on 2 iterations as well. Let's cook. Then, okay, let's check the difference. Okay. Let me check. Okay, so yes, we do actually have a difference. So in theory, we could just start increasing the iterations to quite high amount. And it should not destroy a lot of the detail because the search radius will decrease every time. So basically with every iteration, it will start to filter smaller and smaller areas. I think this did a pretty good job. Okay, I'm just going to copy this there just to get rid of the groups because we do not need them anymore right now. And we have one remaining thing to do, and that is because we actually updated all the biome indices. you could actually see, okay, here it still matches. But if we go down here, we probably start to see, yes, that the biome indices do not match the biome names anymore. So we can rectify that using another simple wrangle and actually fetch from the table import directly. Scene view. And because the biome index is equal to the point number of the biome here, we can just query it using the point number. So s underscore biome name equals the point from the first index underscore biome name, and then we're going to use the biome index. So now all the biome names should match again. Yeah, okay. We assign biome names. Okay. So that's the end of this part of the tutorial. We're going to quickly save our cache. So let's add a new file cache, just so it doesn't automatically recook. Now I'm going to be, just to be sure that I keep my naming consistent. Biomes. And I use lowercase, so I want to be consistent and actually use lowercase here as well. Yes, okay. And now it will probably create an error because the cache does not exist yet. So we're going to save to disk and let everything cook again for a little while. Now, this is actually going to take like 30 seconds or so. Yes. So yeah, in the next set of these tutorials, we're actually going to use again all these biomes to add some more decoration to this terrain using the biome settings. But for this set of the tutorials, this concludes this part of the series, let's say. So let's save again, and I hope to see you next time.